Yeah, my presentation today is in two halves, if you like. First, I'm going to tell you a little bit about Powell Dobson Architects and our approach to sustainability we've developed over the last 15 years or so. And then, secondly, we'll talk about Project Alex and something a little bit about the twin wall technology. So, firstly, in terms of sustainability, a good place to start the conversation about in regard to sustainability is in regard to legislation and legislative context. As you probably know, the Welsh Assembly has taken over the building regulations of this year, and they have some ambitious standards in the next few years, notably in 2014 for non-domestic buildings and 2015 for dwellings. The consultation has been returned earlier this year. It's still kind of up for discussion, but we'll see how that transpires. But it's certainly the case that the next 10 years is going to be a transformation in terms of sustainability, ended in 2016 and 2018 with zero carbon buildings. And we're well advanced in that regard. I'm not quite sure what exactly zero carbon might mean, but it's safe to say that within the next 10 years, the building will be transformed in terms of our expectations in regard to sustainability. In regard to Welsh planning law as well, Wales has its own planning system, and that sets targets for sustainability in regard to BREEAM. There's also commercial opportunities which drive sustainability. Feed-in tariffs, renewable heat incentives, the Green Deal are all commercial opportunities that people are using to pursue greener policies. And in addition to that, sustainable branding and CRC's carbon reduction commitments. Companies like B&Q and Marks & Spencer, who we work with, are very keen on using the opportunities that they're already pursuing in regard to obligations to reduce carbon, to see what they can do as a test bed to progress that agenda further. In terms of Powell Dobson, our approach over the last 15 years has been to say, well, we want to be ahead of the game. Even from the early days, 15 years ago, designing 4 Arps with Arps in Cardiff Bay, we designed a low energy building that has a lot of the characteristics associated with low energy offices, exposed thermal mass, natural ventilation, solar shading, good sensible orientation. It's an agenda we've pursued the last 15 years. If you look at the diagram to the yellow line, that's the standards for building regs over that period of time. And consistently we've been designing buildings which improve on that. And more recently, over the last 3, 4, 5 years, we've had some very successful schemes which are either zero carbon or zero negative. For instance, there's Newport Old Town Dock, which is the largest zero carbon scheme, Code 5 level scheme in the UK. The Welsh Assembly offices, which is 55% reduction in Aberystwyth. And Tata Developments down at just down the road, which again is zero carbon using energy from waste sources. So we think we've put sustainability at the heart of our agenda and are pursuing it in a very aggressive manner. At the heart of our approach is to say, well, let's think about the fabric first. What we need to do is to design a building which is inherently energy efficient. And if you look at the kinds of initiatives you can use to reduce the energy consumption of a building, and list them in terms of increasing cost, if you look at the first sort of half a dozen or so, most of those are architectural elements. The massing of a building, the orientation, the airtightness, daylight, passive cooling, the material selection and insulation and controls. All of those things are well within the remit of an architect, and they're generally the sorts of things you consider at the very end of a building process. And those sorts of initiatives can easily demonstrate a 25% reduction on carbon emissions without really having to rely on renewables, expensive renewables. However, we have a proven track record in terms of delivering various standards of buildings from best practice, whether it be a Band A, B, C construction and a BREEAM Excellence Certificate, through to innovative zero carbon buildings, or beyond that to the groundbreaking schemes which is zero carbon in a truer sense. It takes into consideration the wider energy use of light fittings and such like. So we think that the fabric is important, but in addition to that, recognising that depending on what kind of carbon reduction targets you're aiming for, inevitably renewables do play a part in that. And we have a commercial approach to the selection of renewables, one which by which we say, we look at a list of the renewables technologies available, rank order them in terms of what can give you the biggest bang for your buck in terms of cost, and then say, well, of those potential options, which of those technologies are right for the site? Some technologies won't be right for certain particular sites. For instance, certain technologies, because of their urban location, might not be appropriate because of biomass delivery. Similarly, Now we also look at it from the perspective of what's right for the building. For instance, wind turbines aren't very compatible with residential areas. And similarly, we also look at it from the perspective of what's right for the client. Because some clients have good track record with certain technologies and prefer to use them, whereas other clients really kind of have some preferences to not use certain technologies. So our approach is to say, well, what's right for the site, what's right for the building, what's right for the client, and by a process of elimination, arrive at a cluster of 1 or 2 options for a particular building type. In addition to the fabric energy consumption and the use of renewables, we're also interested in the facade engineering of the project. This happens to be a scheme we're working on for B&Q at the present time. And B&Q come to the table and they have a much broader agenda when it comes to sustainability and in regard to material selection. For instance, there was a time not so long ago when if you wanted to select a material which was sustainable, you go to the Green Guide, you'd select a particular range which is A-rated, and that would sort of be the be-all and end of it. However, more recently, in the last 5 years, there's been a much more demanding set of criteria being placed on the selection of materials, and we consider a wider range of issues now to make an informed decision. So in addition to looking at the Green Guide, we also look at the embodied energy of a particular project. We look at the recycled content that's been mentioned. We look at the airtightness of particular forms of construction. We also look at the legacy waste. How much of that construction will go to landfill as a result of waste. And through that process, we can fine-tune the selection process of materials. For instance, in choosing between composite cladding panels on the rear of the building, on the B&Q facility, we chose a mineral wool-based product which delivered both the lower embodied energy and the lower legacy waste. And similarly, on the front of the building, when we had a choice between a fibre cement and a composite cladded version of that, while we accepted that the composite cladding kind of was a higher embodied energy, we wanted a much higher performance in terms of airtightness, and that led us down to that particular selection. So we used a much broader criteria selection process to inform our decision-making process. In addition to that, we're also interested in embodied energy of the building. This is a particular scheme down at Swansea again. This is Swansea University second campus. And doing the design and construction of this facility, we're looking at the embodied energy of the systems used in the construction and opportunities to reduce the carbon footprint of it. For working with Vinci, the contractor, we've put together various options for them in terms of the potential materials we could use, and exploring opportunities such as replacing the inner skin of the construction with structural fabrication systems to reduce the blockwork construction, lightweight metal decks on the roof construction to avoid concrete precast planks, and the avoidance of composite precast panel construction. And through a various discussion and dialogue, we've grouped the particular options into 2 or 3 options, and we fine-tune it. At the moment, we're looking at option B, which generates a 23% reduction in embodied energy, and we're pursuing other options now to reduce it further if we can. We're also into, I think there was some discussion this morning about RAP. We're also interested in waste minimisation. And if you were to describe a building process from the commencement of a project through to its demolition, from the extraction of materials, the design, the manufacture of components, the assembly into the building operation, for those various stages, there's opportunities to use recycled components. For instance, at the design stage, we can reduce the amount of material used by having, for instance, open plan offices, not necessarily putting suspended ceilings into situations, considering floor finishes, not necessarily put them in all areas, and that's considering self-finished floor finishes. In the process of manufacturing the specification, we can look to improve the recycled content through RAP assessments. And in the assembly of a building, we can look to reuse components. For instance, at the RSPB at Newport, we used recycled heating pylons from Tata as pylons as foundations in our facility there. So in addition to at various stages of the project, there's initiatives we can use to reduce the amount of material used and improve recycled content. And the tools we use to control that are RAP assessments, site waste management plan, and design for deconstruction policies. Now, traditionally, they tend to be sequential. So the RAP assessment might be led by design teams. Site risk management plans might be led sometime later by contractors, where design for deconstruction might be led by structural engineers and civil engineers, probably during the construction process. Again, at the B&Q facility at Cyfarthfa in Merthyr, the approach there was to engage in all those initiatives front of house, early days in the design process, which allowed a collaboration, so the architects and the design team could get involved in the site risk management plan, and similarly the contractor could look to see what they could do in terms of recycled content and source and supply chain issues. But those means we kind of retain material on site. We improved the recycled content of that particular building up to 30%, which is quite an achievement, considering that, you know, essentially what you have is a large empty volume. And we've designed for deconstruction to minimise the waste to landfill by around sort of 10% at the end of life. We're very interested in the broadest definition of sustainability. We're also interested in BREEAM. In-house we have a series of BREEAM assessors. I'm one of them. And that allows us to fine-tune BREEAM assessments and ensure testing conditions where BREEAM is a condition of planning requirement, a condition of planning permission quite often, that this is managed in a very efficient manner. But importantly, in terms of Project Alex, BREEAM over the last few years has been extended and revised, and now it's very relevant to refurbishment of buildings. Only about 1% of buildings in the UK are sort of a new build. Most of the buildings are in existence, and in the next sort of 10-15 years, once we get over this initial sort of period where the legislation for new build is going to be kind of rationalised, there's going to be an imperative to reconsider and hone down on how we kind of deal with our existing housing stock and existing building stock, particularly in an urban environment. So that was the first half of the presentation. The second half is specifically about Project Alex. Yvonne is here, she's the project architect, she's here if you have any questions or technical queries, but I'll present the scheme to start with. So Project Alex is the home of the ISD. It's it will be located in a Grade 2 listed building, which is the old library. It's part refurbishment, part new build, part extension, which you see to the right. In terms of its general for those who know Swansea, it's located on Alexandra Road, opposite the Glenvivian Art Gallery, and sits in this triangular plot of land between Orchard and Pleasant Street. The town centre is just off to the right. The coast is off to the right as well, in the north, off to the north of the page. And importantly, that facade which faces onto Pleasant Street, which is where the new extension is being located, faces directly south. So in addition to having a very pleasant environment in terms of when the sun does come out, being sort of very pleasantly bathed in sunlight, it also has some challenges environment in terms of potential solar gain. In addition to that, the location of the site in a landlocked kind of road, heavily, or at least moderately trafficked area, with potential noise issues, led us towards the potential use of a twin wall to resolve those sorts of issues. So the new extension to the site, which houses that twin wall, is in a way had technical exercise in terms of resolving some of the site issues, in terms of developing an entrance for the site which is more accessible, allowing the goods entrances to be arranged in a more convenient fashion, providing some extra accommodation. But for me, the real benefit, or the real purpose of the project, is to really allow the ISD to say something about themselves, to give shop front and a shop window to their campus, and say something about themselves, using glass technologies, innovative manufacturing, and sustainable design in a way which collaboratively works together. The location of the twin wall, this is Pleasant Street, and the twin wall, as you say, is this long elevation which faces due south. The building and the development has a range of sustainability initiatives in pursuance of its BREEAM assessment. However, the twin wall is probably the most important in terms of our presentation today. For those who are not familiar with twin wall, essentially the basic system is two series of glass planes with a void between them, into which breezeway is selected, which gives you certain benefits. If you're interested in passive design, as architects we are, one of the key fundamental areas you try to progress at the early stages is to try and naturally ventilate as much of the building as possible, to avoid use of mechanical ventilation. However, in urban environments which are potentially noisy or potentially have a certain amount of pollution associated with transport, that tends to be a barrier to natural ventilation. However, twin wall effectively creates a buffer which allows you to exclude as much of the noise as possible while still maintaining comfortable conditions using that buffer zone to mitigate the worst of the solar gain. In addition to that, there's tertiary benefits. In addition to lowering the energy consumption, reducing pollution, reducing noise, it also has some certain benefits in terms of security. So in a situation where you might have this parcel accommodation which has IT facilities, not having openable windows to face direct out the street has a secondary security benefit. In terms of the elements of the twin wall construction, on the outer skin you have a fixed glass wall which has no windows in it. On the inside of the facade, inside of the building, you have a second glazed skin which has the majority of the active elements, the openable windows. That forms a chimney, an air gap between them, which with the intervention of an airlet at the bottom and an exhaust louver at the top, in effect creates a chimney. So where passive solar gain is collected inside that void, the air heats up and effectively stack effect draws the air through that plenum. And as that air draws through the plenum, that creates opportunities to control it in several different ways. In the winter, or in the mid-season, the spring and autumn, where there's a reasonable amount of passive solar gain around, that passive solar gain can be collected in that buffer zone and used to breathe that air. So the air inside that shaft is slightly warmer than ambient outside air. And then that air can be allowed to be brought into the building and effectively offset the heating cost. So that passive heated air in that plenum can be brought into the building, slightly warmer than ambient temperature outside, and that offsets the heating cost and reduces the energy consumption. However, in the summer, where potentially there is a little bit more challenge in terms of overheating and kind of solar gain, those windows can be closed down and the heat can be rejected and the mechanical ventilation system can supplement the natural ventilation and avoid the overheating. So it's a hybrid system that sort of works in the winter and the mid-seasons to offset heating costs, allow kind of natural ventilation, mitigate noise control, noise pollution from the outside, and then in the kind of the challenging summer times, it can also exclude the solar gain. So the system on the inner skin of the building has a series of kind of manual operation and automation. So in terms of the automation, you have a series of air temperatures inside that shaft, inside the buffer zone, and then inside the building, which monitors the temperatures in those three zones and automatically, through a use of a building energy management system, a computerized system, and motorized windows to self-administer the ventilation of the building. So the occupant doesn't necessarily have to get involved with it, particularly in an atrium situation where there might not be any kind of occupants available to manage the windows. The system manages itself. However, there's also supplemental manual openable windows, which people can kind of open if they feel they want to, or if they feel they need additional fresh air. Then in terms of that lower kind of section of the construction, you have a series of air intake louvers which are actuated or kind of vary in terms of the amount of free area they allow and the amount of air they allow in. So winter, where you want kind of a nice airtight construction, the louvers can close down and create a nice sort of airtight form to the building so that the heat is kept in the building. And then in the mid-seasons, kind of some fresh air can be allowed in. And then kind of in the summer, they're open fully and you can purge the twin wall completely of solar gain. Similarly, at the top, you have an extract system whereby there's a series again of actuated louvers which allow to control the air in that void and mitigate the worst of the summer temperatures. In terms of the construction process, it's on site at the moment. This is a view of the faculty from Pleasant Street. This is the end of the listed building facade, and you can see this has a slightly back-of-house character at the moment, and the building eventually, when it's constructed, will transform that part of the site and create an intervention which is quite dramatic and really signals a new kind of era for the university and a new area for the institute as well. So thank you very much for listening. That's all I want to say today. Thank you.